welcome back. Today we're doing something really cool. We're gonna build that iconic, that unmistakable police siren sound. And we're gonna do it from scratch, using one of the most famous little chips ever made. This is gonna be fun.
I mean, you know the sound, right? That rising and falling wee-woo that just instantly gets your attention. But have you ever stopped to think, how do you get a pile of simple electronic parts to create something so dynamic and recognizable? Well, that's the mystery we're cracking today.
So really, how is it made? You might think it's some super complex thing, but the secret? It's surprisingly simple. When you break it down, that wee-woo sound is just a single tone that's being flipped really fast between a high pitch and a low pitch, over and over and over. The real magic is in making that switch happen all by itself.
And to pull off that magic trick, we need a hero. And the hero of our story today is this little guy, the legendary 555 Timer IC. This tiny 8-pin chip is the absolute key to unlocking our entire siren circuit. It's got to be one of the most versatile and, honestly, beloved components in the entire world of electronics.
And get this, it's been around forever. It was introduced all the way back in 1972. I mean, think about that. For decades, this little powerhouse has been the cornerstone of countless projects for both hobbyists and pros. Its genius is just how simple and reliable it is.
Okay, so the 555 can do a bunch of different things, but for our siren, we're using it in what's called astable mode. Now, don't let the name scare you. Think of it like this. You're turning the chip into a little electronic heartbeat. It just sits there and outputs a continuous, repeating on-off pulse. Tick-tock, tick-tock. All on its own, no trigger needed.
And here's the best part. We have total control over the speed of that pulse, its frequency. All we have to do is change the resistors and capacitors we connect to it. Want it faster? Swap a resistor. Slower? Swap a capacitor. This little trick is absolutely crucial for building our siren.
Okay, so one 555 timer can make a steady pulse. That's cool, but how do we get that wee-moo effect? Well, here comes the secret sauce. The big reveal. We're not using one 555 timer, we're using two of them. And they work together in this really clever way to bring the whole thing to life.
So how do two timers work together? Well, just think of it like a tiny orchestra. Timer number 1 is our conductor. We set it up to be really, really slow, like 1 or 2 beats per second. Its job isn't to make any sound we can hear. Its job is to wave the baton and tell the musician when to change notes. Now, timer number 2, that's our musician. We set its frequency way up high, so high that when we run it through a speaker, we actually hear it as an audible tone. This is the guy making all the noise. So the whole thing hinges on how they talk to each other. We take the output from our slow conductor and we connect it directly to a special input on our fast musician. It's called the control voltage pin. It's like a puppet string. When the conductor's output signal goes high, it pulls on that string and tells the musician, speed up, and we get a high-pitched tone. Then, when the conductor's signal goes low, it tells the musician, slow down, and we get a low-pitched tone. Wee-woo, wee-woo. It's just that elegant little interaction creating the entire effect.
Okay, enough theory, right? Let's talk about actually building this thing. Let's get our hands dirty. It's honestly way simpler than you might think, and it uses super common parts that we'll check out right now. So here's your shopping list. You're going to need 2 of those NE555 timer ICs, of course, then just a handful of really common resistors and capacitors. These are what set the speeds for our conductor and our musician. You'll also need a little 8-ohm speaker, a breadboard to put it all together on, some jumper wires, and yeah, a 9-volt battery to give it some juice. That's pretty much it. Putting it together is super straightforward. First, you'll build the slow conductor circuit on one part of your breadboard. Then, right next to it, you'll build the fast musician circuit. Then comes the most important step of all. You make that critical connection from the output of the first timer to that special control pin on the second. After that, you're pretty much on the home stretch. Just hook up your speaker, connect the battery, and you're good to go. I'm going to say this again because it's that important. This single wire, from pin 3 of the first timer to pin 5 of the second, is the absolute heart of the entire project. It's the whole magic trick. Without it, all you have is a boring, constant drone. But with it, you get a siren.
All right, so you've built the circuit, you've double-checked all your connections, you've got the battery ready, there's only one thing left to do, and that's to hear what it sounds like.
The second you connect that battery, bam! You should be greeted with that classic wee-woo sound. And the cool part is you can totally play around with it.
If you swap out the components on that first conductor timer, you'll change how fast it switches between high and low. And if you change the parts on the second musician timer, you'll change the actual pitch of the high and low notes themselves.
You know, this little project is awesome because it shows off some really big ideas in electronics. We've seen with our own eyes that the 555 is just a fantastic little oscillator. We've also learned that you can take two really simple circuits, put them together, and get a much more complex and dynamic result. And most importantly, we've seen how frequency creates the pitch of a sound. And we've proven we can use a simple voltage to control that frequency.
So there you have it. We've cracked the code of the police siren. It's just a perfect example of how a few simple parts, when you use them in a clever way, can create something seriously impressive. It really makes you wonder, right? If two little 555 timers can do this, what else could we build with this amazing little chip?